Welcome. In this video, I'll be talking about linear equations in three unknowns. Specifically, we're going to talk about what happens when two linear equations involving three unknowns intersect, or how they intersect in the column picture and the row picture. So when dealing with so please subscribe and comment, okay? So when dealing with two linear equations involving three unknowns, let's say x, y, and z, we're dealing with geometric representations in a higher dimensional space. So what is the row picture? The row picture of two linear equations in three variables will show two planes in three-dimensional space. Each equation represents a plane, and the solution to the system of the equation is the intersection of these two planes. So for example, if you look at this system of equation 2x plus 3y plus c equals 5 and x minus y plus 4z equals 6, they will meet at a line. They will meet. They will intersect. They typically lie on a line. The solution lies on a line. Okay, so let's see. So the row picture of two linear equations will show two planes in each equation represents a plane, and the solution to the system equation is the intersection of these two planes. Okay, so it would look something like this, as it says there. So let's say you have a plane in three dimensions. Let's say the plane is here. The other plane might intersect so they will intersect at a so let's say they intersect somewhere. They will intersect at a so the solution will be the intersection of these two planes. Say this is plane 1 and this is plane 2. Say this is x, y, and z. So the intersection will be somewhere here because this goes underneath, so it will be somewhere here. So now let's talk about the column picture. The column picture for this system is also in three-dimensional space, as it involves vector combinations in R3. In this context, we're looking at a linear combination of vectors that form the system of equations. The solution to this system of equations typically lie on a line. This line is the intersection of the two planes, assuming the planes are not parallel and do not coincide. So let's consider the system that we just talked about. So to solve this, we can express one variable in terms of the others. So let's see if we can do that. So you have the system 2x plus 3y plus z equals 5 and x minus y plus 4z equals 6. So z is by itself, so we can solve for it. Okay, so that's what we're gonna do. We're going to solve for z on the first one. So this will be 1, this will be 2. So solve for z on 1. Then we have, if we solve for c, then we have z is equal to 5 minus 2x plus 3y. Now we're going to substitute this expression for z into the second equation. So for example, z is here, so we're going to do, now we're going to do substitution of z on 2. That means that x minus y plus 4 5 minus 2x plus 3y equals 6. Now we're gonna, so that simplifies to x minus y plus 20 minus a x minus 12y equals 6. And if we combine like terms, we're gonna get negative 7x minus 13y minus 14. So this turns into negative 7x minus 13y equals negative 14. Now let's try solving for y. So, but since they're all negative, we can turn everything to positive. Now we can solve for y. That would be 13y is equal to 14 minus 7x all over 13. So y is equal to 14 minus 7x over 13. So let's erase something here. Now we're gonna substitute back into the equation for z. Okay, so we said z is equal to 5 minus 2x plus 3y, and we can plug in y here, or just found. So that's equal to 5 minus 2x. So everything, so z is gonna be in terms of x. So that will be 14 minus 7x over 13. Now we simplify and solve for x. We can see on the screen here on the right side that we're gonna get that z is gonna be equal to 65 over 13 minus 15x, 5x, it should be 5x over 13. Okay, so now let's put everything together. So we're gonna have, so let's put everything together. So in parametric form, so in parametric, then we have the solution to be the solution of the system is, so we let x is equal to t, and then y we found it to be 14 minus 7t over 13, and then z is equal to 65 over 13 minus 5t over 13. So as you can see, x, y, and z is in terms of t, so it's in parametric form. So what we did before is we solve for each variable in terms of x, and now we let x equals to t, so we let a free variable. So t is at the parameter, so t is a parameter. And this shows that we found the solution, and the solution as we said, for a system of two linear equation of two linear equation and three unknowns, is typically lies on a line. Yeah, we said that at the beginning here. The solution to the system of equations typically lie on a line. Yes. So thank you for watching. Please subscribe and comment. Thank you very much. See you soon.